Hi everyone, Mr. McCray back again. Video time. Yes, we are starting back at school after Thanksgiving break. I hope you guys did have a great break. So today's focus is going to be on one-step equations. All right, I think most of you guys know how to do this stuff, but this is kind of review. Later on this week, we're going to be getting into two-step and multi-step equations. So it's going to get a little bit harder, and then it's going to get harder and harder and harder and harder. And this concept's going to probably go about 3 weeks. So there won't be any quizzes. There will be one big test that everybody that we'll have to do. Okay. So one-step equations. What the heck are we talking about? Okay. So I think we remember one-step equations from a long time ago. Most people have done this. You have a value of x, which is the variable, plus 3 equals 12. So you use the one-step equation to basically figure out, okay, what's the value of x that will make this satisfy the equation to make this 12. Okay, and I think we remember how to do that, right? We first of all we take the inverse operation of the value on the left side here. Okay, just kind of lagging on me. I haven't done this in a week, so okay. So we have to take the inverse of the first value on the left. So if you look at it here, we have a number plus 3 equals 12. So if we go to this little table I made, this is something that's going to be in our notes. Basically, it says this is the operation, and here's the inverse of that operation. So if you think about it, we have on the left side here where I put the border down the middle, I have x plus 3. So that's addition would be the operation that's going on here. Now, to do the inverse, to find out what the value of x is, we have to do the inverse of that operation, which would be subtraction. Okay, so therefore, I would subtract 3 from both sides of the equation. Now, this is also called, this is actual property by doing this. This is called the subtraction property of equality, but we're not going to really go into that because I think that's kind of a waste of time for us to talk about right now. All right, so let's finish this off. So basically, like I said, I just get a minus 2, 3 from either side. And so what happens, plus 3 and negative 3 cancel. And then I have 12 minus 3, which give us 9. Okay, and the x drops down because that's the only thing that's left. And then I have 12 minus 3, which is equal to 9. So the value of the x value is 9, okay, using one-step equations. I think we all know how to do this from before. So that's going to be pretty easy. But, of course, like Mr. McCray likes to do it, we're going to get a little bit harder as we go along in the process. So pay attention. Okay, let's look at the next one. Man, I'm writing bad today. Jeez. All right, so let's look at the next one. We have a value of x. Okay, we're going to put that over 3. Okay, and then we're going to equal that to the value of 12. Oh my God, hold on a second, guys. Man, is that bad writing? I can get my pixel control here again. There we go. All right, good. So we have value 12. So I'm going to put a little line down the middle to make it easy to remember what side of the equation. So let's think about this here. This is one of the ones that a lot of people have an issue on, okay? It's like, what the heck? What's the value of x here, okay? So the first thing you need to think about, what is the operation that's going on the left side of the equation, okay? Now, if you think about it, we have a fraction here. So what do we do when we have a fraction? We're basically dividing the numerator by the denominator. So therefore, the operation that we need is division, okay? And therefore, the inverse operation would be multiplication. So we look right at this one right here. Okay? So, therefore, okay, I would just basically take the bottom numerator and multiply, find a value, and multiply by the same amount. So there I have x divided by 3, so I'd multiply by 3. Get this here, let's set this down. Okay, multiply by 3. And I'm going to do the same thing to the other side. I'm going to multiply 12 by 3. Okay, so again, that would cancel this side of the equation, and you'd be like, what the heck, why is that canceled? Because again, if we made this into a fraction, okay, we cross-cancel 3 and 3 because they're factors of each other, and then we would just multiply 1, it would be x over 1, so that would just be x, all right? So let me bring the x down, after I do that. Okay. And then I would have 12 times 3. 12 times 3, which is equal to 36. Okay, 36. And that would be the answer to that question. All right. So that's exactly how you would do that situation. So again, this little thing of this inverse operation is very critical. If you want to write that down, I'm also going to make a note copy of that and put it in the Google Classroom as well under the unit 2. So hopefully you can make sure you have that so kind of go over it. I didn't go over this at the end, but at the bottom you can see that I did say square root and exponent, that they are inverse operations of each other. Okay, the square root, which you guys have seen, but that's kind of like 10th, 9th, and 10th grade that you're going to talk about that. I think 10th grade more than anything. Okay, you'll start talking about that stuff, but just to give you an idea, square root and exponent are inverses of each other. Okay, so that's just helping you out for later on. Okay. Let me do another problem, and like I said, and then I'll do two more problems, and then we will go on, and you guys can do your own work. Okay, so this one I would have, let's go 3. Let's make this an x minus 5.2. Okay, so let's look at this one here. Okay, so now we have, it's kind of messed up. We have it all different places. Now we have the expression on the right-hand side and now the answer on the left. So how do we do that? Okay, nothing changes. Just think about what the what the operation expression is using. So if you think about it, we have subtract here. So the inverse operation would be add. So again, I just add 5.2 to both sides. And then that would be 8.2 equals x. And this cancels. And I'd be done. Perfect. And that's how it would work. Okay. I think we get the idea here. I'm going to do a couple of harder problems on the next page just to give us some opportunities to see in terms of fractions, because that's what we're going to be doing some portion of the day. Is working with fractions as well with this one-step equation, because we do need some review on that as well. So, okay, we'll move on to the next page here. I'm not going to do the inverse operation tree. I think we get that whole concept on this side. All right, let me finish this up so we can make this get going here. All right, so let's go with an example of 2/3. Okay, plus x equals 2. Okay, 2/3 plus x equals 2. All right, now same situation here. Okay, we remember this is on this side of the expression we have addition, so that would be subtraction. So I would subtract 2/3 from both sides of the equation. Okay, and I'll do 2/3 here too. Okay, so we know this one cancels. That one's easy. Now, how do we do this one? We have 2 minus 2/3. So how can we work that to make that work? Okay, so the easiest way to do that would make this into a fraction and a mixed number. And the way you can do that is you want to put 1, and then you want to put 3/3. Okay? Now, the reason why I did 3/3, because my denominator is 3 as well. So that would make it easy for me to minus 3/3 minus 2/3. Okay? And I can keep my 1 by itself. So if you remember from subtracting fractions, well, that's a terrible 3 right there. Jesus. Okay? Okay? And then from there, basically, I would just carry down the 1. If I get pixel control here, I'd carry down the 1, and I make this 1/3. Okay? So, and if I wanted to turn that into like a fraction, basically I would multiply 3 times 1 plus 1, and that gives me 4/4, if I need to do that. There you go, 4/3. So therefore the answer is x equals 4/3. Okay? And that's how how you would do it. Basically the same thing. Again, this might be a little bit hard for some people, but we can work through it and practice it over a period of time. Okay, so we're going to be doing some problems like that as well. So that'll be more challenging, but I think it's going to be fruitful here, you guys, to be working on fractions as well, because we're going to need it as we get in more into graphing in that portion of it. Okay, and the last problem. Okay, we have 2/3. This one's probably the hardest one you're going to see today in your work there. Okay, I have negative. Let's go negative 2/3 x equals 1/3. Okay, now remember what we said. Now we put a line down the middle to represent the expression in the answer. So we have negative 2/3 times, since we don't have anything in the middle, times a number equals 1/3. So if we have times, the operation is multiplication, okay, then the operation that's the inverse is division. So we have to divide both sides by negative 2/3. Okay. You say, why negative 2/3? Well, we want to do negative 2/3 because the x has to be positive. Okay. So it's always got to be positive. So this is x has to be positive. Okay. When you do this kind of stuff. All right. So now here's the hard part. We got 1/3 divided by negative 2/3. So remember from fractions, let me do this here. Let me make my division sign and we do the negative 2/3. Okay. All right. Again, this is a lot of review practice, but this is kind of stuff that we need. Okay. So 1/3, you got division sign, negative 2/3. So again, the rule is keep, change, flip. Okay. So again, 1/3 times, okay, and then flip the whole value so you get 3. Okay, over negative 2. Okay, so again, if I do my math here, cancel these out. That becomes 1, that becomes 1, and this thing becomes 1/2, and that would be the answer to the question, negative 1/2. All right. So again, keep, change, flip. If you have the values of the fractions, we haven't done that in a while, but it's a good practice for ourselves to kind of practice that. And that will give you the answer of 1/3. There will be a couple problems like this in the work for today. Please try your best, and we'll go over it during review time, and we'll get going. But those are the problems that we'll see in the one-step equations. Like I said, next week we'll start talking about two-step, and not next week. Thursday and Friday class we'll start talking about two-step and multi-step. Okay. All right, guys. Thanks.